How did the universe begin from nothing? This is probably one of humanity's oldest, most profound questions. I mean, think about it. Has there ever been a single person who looked up at the night sky and didn't wonder? Where did all this come from? When did it start? And was there really a time before everything, a time of absolute nothingness? For centuries, this puzzle has captivated everyone, from philosophers to scientists. For a long time, we thought we had the answer. The Big Bang. You know the story from the textbooks. A universe starting as an infinitely hot, dense soup of particles. In a flash, it explodes, expands, and cools, creating everything we see today. It's a dramatic, chaotic, and powerful image. But what if I told you that this classic story is being written? Modern physics is painting a new, even more mind-bending picture. It suggests that at the very beginning, there was no Big Bang. At least not in the way we've always imagined it. The universe didn't just pop into existence as a giant fireball out of nowhere. It was more like a transformation, a phase change. There was a state asterisk. Before asterisk this one, and that state was anything but nothing. In fact, it was far stranger and infinitely more fascinating. The quantum vacuum. Let's unpack this from the start. What exactly is this quantum vacuum? First, we need to understand why the empty space all around us isn't actually empty. Imagine you take a room and empty it completely. You take out the furniture, you pump out all the air, you even block out every last photon of light. It seems like you're left with pure nothing, right? Well, according to quantum physics, that's just an illusion. There is no such thing as truly empty space. Space itself is an ocean of invisible, energy-filled fields. This state, which we call the quantum vacuum, is constantly humming with the vibrations of these fields. You can't see them, you can't feel them, but they are always there, shifting, fluctuating, and bubbling with potential. And this isn't just a wild theory. It's been measured and confirmed in laboratories. Take the Casimir effect. For example, if you bring two perfectly smooth metal plates incredibly close together in a vacuum, something strange happens. They get pushed toward each other. Why? Because the vacuum energy asterisk between the plates is slightly lower than the vacuum energy asterisk outside them. So, the empty space around the plates is literally pushing them together. Even nothingness has force. Then there's something called zero-point energy. This is a fundamental rule of nature that says nothing can ever be perfectly still. No matter how much you cool something down or how much energy you try to remove, there will always be a tiny, residual vibration left. It's like nature has an allergy to absolute silence and stillness. This means there's no absolute emptiness, and everywhere, literally everywhere, is filled with a baseline level of energy. The very concept of nothing starts to lose its meaning. So, if space isn't empty, what's happening in it? This is where the magic really begins. Thanks to a quirky rule in quantum mechanics called Heisenberg's uncertainty principle, the universe has a kind of cosmic credit card. It can borrow energy from the vacuum for incredibly short moments, as long as it pays it back quickly. And what does it do with that borrowed energy? It creates particles. At every single point in space, all the time. Pairs of virtual particles are popping into existence and then vanishing almost instantly. Electron-positron pairs, photons, gluenza, whole zoo of particles flickering in and out of reality. We call them virtual because they don't stick around, but their effects are very real. They subtly shift the energy levels of atoms. They can distort electric fields, and they basically make the vacuum of space behave like a pot of simmering, invisible water. This constant bubbling is the default state of reality. Nature doesn't allow for quiet. Something must always be happening. Now, what if one of those tiny fluctuations didn't just disappear? What if it grew into something much, much bigger? This brings us to what might have happened before the Big Bang. You see, the quantum vacuum doesn't just produce tiny particle pairs. Every now and then, a much larger, more significant fluctuation can occur, getting trapped in an unstable, high-energy state. Physicists call this a false vacuum. Imagine a vast, supercooled lake that's still liquid, even though it's below freezing. It looks stable, but it's incredibly fragile. A single disturbance, a tiny crystal of ice, can trigger a chain reaction, and the entire lake freezes over in an instant, releasing a huge amount of energy as it settles into its more stable, icy state. Some of our leading physicists believe our universe began with a similar event: the collapse of a false vacuum. The enormous energy trapped in that unstable state was suddenly released. And this release didn't just create heat, it forced the fabric of space-time itself to expand at an unbelievable, exponential rate. We call this incredible period inflation. Today, the scientific community is almost certain that this inflationary epoch happened right before what we call the Big Bang. We're talking about the very first moments of existence. In a fraction of a second, something like 10 to the minus 35 seconds, the universe doubled in size, and then doubled again and again, trillions of times over. It grew from something subatomic to something astronomically large in the blink of an eye. But here's the most surprising part. During this hyper-expansion, the universe wasn't hot. It was actually incredibly cold and seemingly empty. The blistering heat of the Big Bang only came asterisk. After asterisk, inflation ended. Think of it like this. The energy that drove inflation was stored in the vacuum field itself. When inflation finally stopped, that stored energy had to go somewhere. It was dumped into the universe, instantly converting into a hot, dense soup of matter and radiation. Asterisk. That asterisk moment, when the universe heated up, is what we traditionally call the Big Bang. So the sequence of events is actually a quantum vacuum state leads to inflation, a cold, empty, rapidly expanding phase. Then, inflation ends, its energy is released, and the universe suddenly becomes incredibly hot. That's the Big Bang moment. From there, the universe cools, and atoms, stars, and galaxies begin to form. In short, the Big Bang wasn't the beginning. It was the consequence of a transition from a previous, even more mysterious state. How do we know any of this is true? We can see the evidence written across the sky. The cosmic microwave background, that faint, ancient light left over from the early universe, is essentially a baby picture of our cosmos. And on that picture, we see tiny temperature fluctuations, tiny hot and cold spots. Those spots are the fossilized imprints of the original quantum vibrations from the vacuum, magnified to cosmic proportions by inflation. The fact that our universe is so flat and looks pretty much the same in every direction is also a natural prediction of the inflation model. And the story of the vacuum doesn't end there. It also determines our future. In 1998, astronomers discovered that the expansion of the universe isn't slowing down. It's speeding up. What's pushing it? A mysterious force we call dark energy. And the best candidate for what dark energy is, it's the vacuum energy, the energy of empty space itself. About 68% of our entire universe is made of this stuff. So, the nothingness that started it all is also shaping its ultimate destiny. So, if the Big Bang wasn't the absolute beginning, what came before it? Scientists have several fascinating ideas. One is the Big Bounce. In this model, our universe may have existed before, but in a contracting phase. It collapsed down to an incredibly dense point. But quantum effects prevented it from becoming a true singularity, causing it to bounce back and begin expanding again. This could be part of an endless cycle of collapse and rebirth. Another idea is the ekpyrotic model, which comes from string theory. It suggests our universe is a three-dimensional brain floating in a higher dimensional space. The Big Bang might have been triggered when our brain collided with another parallel brain. Then there's my personal favorite, eternal inflation and the multiverse. This theory suggests that while inflation ended in our pocket of space, it continues raging on in other regions, constantly spawning new bubble universes. Each bubble could have its own unique laws of physics, different particles, maybe even different dimensions. Our entire observable universe would be just one bubble in a vast, eternally inflating cosmic foam. Some models even suggest that time itself isn't fundamental. The famous Wheeler-DeWitt equation, which tries to combine quantum mechanics and gravity, implies that at the very beginning, time as we know it didn't exist. The universe might have tunneled into existence from a timeless, purely quantum state. Time might just be an emergent property, our perception of the universe changing from one state to another. What all these theories point to is a shared, profound conclusion. True, absolute nothingness may be physically impossible. The uncertainty principle prevents perfect stillness. Zero-point energy ensures space always vibrates. Virtual particles constantly flicker in and out of being, and vacuum energy fills every corner of the cosmos. So, saying the universe came from nothing isn't quite accurate. It's more like the universe is a transformation of a pre-existing, fundamental quantum reality. The Big Bang wasn't the moment of creation. It was a moment of transition like steam condensing into water. But on a cosmic scale, it was the moment a prior vacuum state changed phase, cooled down, and allowed the rich, complex structures of stars, galaxies, planets, and eventually, us, to emerge. The universe may be just one part of a much larger, perhaps eternal structure. A structure with no true beginning and no true end. Just endless cycles of change and transformation. And we, as conscious beings trying to piece this story together, are a small but incredibly meaningful part of that grand, cosmic dance. We are the universe's way of looking back and understanding itself. Thanks so much for watching. If you enjoyed this journey to the edge of time, don't forget to like, subscribe, and hit that notification bell for more cosmic explorations. See you next time.